Okay. Okay. Hello, everyone. We are continuing with our question and answer sessions. We are going as scheduled for the Ontotext case. We have the industry experts from Ontotext. We have Atanas here, and we also have Nikola. And I'm looking for questions asked towards your case. There are none so far, but there are questions from me so that we can help out the teams. So first question is, what is the general essence of the case? What is the philosophy? What is the idea that we are expecting from the case?
Okay. So the general essence is automatic classification case. So we have information about a lot of companies that come from Wikipedia, and we want to classify them in industries. We have done so by semi-automatically extracting a classification from the Wikipedia tags, but we want to improve that and find errors. So we want to train a classifier on the existing classes and then predict new classes for unclassified entities. However, we have formulated the case as more as an anomaly detection case because we don't have a gold standard to which to compare. And so we want to see if an automatic classifier can find errors in the already classified data. So this is the essence of the case.
Okay, well, thank you for that. So it is a classification, not really an anomaly detection. It's a classification.
Well, it depends on the way you look at it. It is a classification without a very solid gold standard. So we say anomaly detection in the sense that we are not looking for measuring scores of precision and recall, but we are looking for interesting corner cases, and also we want to see different methods and how people take on the challenge, because it's a very rich data set and there are a lot of features. There are textual features and there are symbolic features.
Yes, and this was my feeling reading the case. It is a lot of feature engineering. It's for the guys who are interested in this type of cases. It is going to be interesting. Okay.
Yeah. Can I say a couple of words?
Yes.
Yeah. So just to tell a bit on the figures. Mm-hmm. So what we actually have is like 300,000 organizations from Wikipedia. But not the full pages. Rather, for each of them, you have title, you have short description, the abstract, and then you have few other features. So you have 300,000 of those, which are classified into the bigger taxonomy of sectors is like 240 different sectors, but they are grouped into 32, I believe, top industries. So the task is to train classifiers for these 32 top industries. So for each of them, you have anywhere between 5,000 and 30,000 representatives. So which is quite a good set.
Yes.
And then the classifier should detect anomalies of two types. This is what Nikola and other data scientists at Ontotext defined. One of them is, for instance, Boeing is formally assigned to belong to the class of automotive companies, which in some tiny aspect of what they are doing is probably true. But obviously, they are not a typical representative of this cluster. So part of the job is to detect for each of the top industries, to train classifiers which can detect such outliers in the sense of company that is assigned to be there, but it is very bad representative. And then the other task is to find companies which based on your classification algorithms should be part of this cluster, but currently aren't. Like Tesla Motors, for whatever reasons, doesn't appear, I believe, in automotive. Well, it should.
Does it appear in IT?
No, it's actually a bit more complicated. Tesla Motors is not a good example.
Exactly.
They actually
are an outlier. Okay.
Yeah.
Okay. Thank you for this clarification. So my next question, I'm going to switch to Nicola first, and if Atanas would like to add, we'll put you through as well. The next question is, what is proposed or suggested steps to solving this case? I know that you have additionally prepared GitHub instruction, which GitHub instruction we have put through in a link in the case, but still give us the outline of the steps for solving the case.
Well, if I were doing the task, I will start small with the provided CSV file in the GitHub repo, in which we have extracted the textual description of companies and the target classes and some other features. I'll train 32 binary classifiers one for each class, and make them predict, and then run them over the full set. And then I would look at corner cases. I would look at first at the type 1 errors, like the one that Tanas said about Boeing. So I would look at companies that are classified in a class, but do according to the automatic classifier should not belong to that class. And I would do an error analysis. Then I would start adding features from other features from Wikipedia and maybe geographic features, and little by little enriching my model.
Okay.
This is how I would tackle the case. Then, depending on the type of classifier, I would favor one type of feature than the other. If I'm training some very complex neural network to do NLP, then I will pour in a lot of text from Wikipedia. For example, there is a query that will give me all the Wikipedia entities that are part of a given industry and all its variants. So basically all Wikipedia pages that have something to do with information technology. So this can generate a bunch of text, and I would feed it into the network to see if it improves and if it starts classifying better.
You said network.
I will go looking Wikipedia to extract other features. For example, I don't know, maybe subjects. There is a Wikipedia subject that says what given industry is about. So if, for example, Boeing will have airplanes, but will also have air travel, military, weapons, I don't know, I'm inventing, but I will go for more symbolic features if I'm training a linear classifier.
Okay, so the outline that I see here is start with train simple classifiers, and then enrich the data to make them more sophisticated. Okay. Anything else you would like to add, or Atanas?
Nothing specific other than like you have the basic data set, as Nicola said, as CSV, so you can take it right away, single line per company with all the features. But then you can see in GitLab there is reference to a public service where you can explore what data we have and easily figure out how to get extra features for specific companies. Nicola had provided some examples, so you can very easily, you actually have online access to much bigger data set. And we can assist you through the chat to make the right queries, to see the right things in the data. We can assist you with the queries to fetch a specific feature. Something that Nicola didn't mention, for instance, but it is in his examples in the documentation. You, for instance, have news articles, really big volume of news articles connected to each of the organizations. So, for instance, you can easily get news that talk about companies in this industry and use it as extra text for training, if it makes sense to you. Yes. You have also links to other Wikipedia concepts that you can literally use as features also. So just to get the categories and the pages that are typically referred out of Wikipedia description of organization in this sector, and so on and so forth. So it's a ton of stuff, but in a way, one can easily look at 3 or 4 or 5 organizations, and you easily figure out what's in there.
Okay, thank you for that.
And just
go ahead.
We have model that we have drawn a diagram that shows how interconnected the data is, and we invite you to look at it. It's in the GitLab project. It's a big diagram to see all. It's not all. It's a really small part of the connections, but just to get a feel how everything is interconnected in this tech.
Yes. Okay. I can see that there were no new questions in that, but we know that I think 2 teams are already working on your case, and probably a few more will join. And okay, with this I would like to thank you for your time and for your kind help. And be active in the chat, and all the guys who are watching this, ask these 2 guys there know what they're speaking about. This is Nicola and Nasu. These are their chat names, and you can find them in the case Ontotext September 2018 data channel. And with this, I would like to thank you for your participation here.
Bye.
Bye.
And we're continuing in about 3 minutes with the Sophia R case question and answer.